So here I come up with the next question, that is y that is equals to sine x, where x belongs to real numbers and domain of f that is real number, then dy over dx that is equals to cos of x. That means the derivative of sine x is cos f. What we have to do, we have to prove this, that this function, the derivative of this function is cos of x. So I am following those steps that I discussed previously, that if y equals to sine x, then the next step is I am going to introduce the term that is del y on the, you can say, left side and del x on the right side. So y plus del y that is equals to sine as it is, and in the place of x I write x plus del x. So this is the, you can say, the second equation. Now subtracting these two equations, I got this equation that is del y that is equals to sine x plus del x minus sine x. Now dividing both sides by del x doesn't matter, and in the next step applying limit on the both sides. So I got this equation that limit del x approaches to 0, del y over del x that is equals to limit del x approaches to 0 sine x plus del x minus sine x over del x. Now in the next step, what we have to do is I write in the place of the limit del x approaches to 0, del y over del x that is equals to dy over dx. So dy over dx that is equals to this term. Now in the next step, what we have to do is I am going to let del x that is equals to h. So limit h approaches to 0 sine x plus h minus sine x over h. In the next step, now I am going to apply the formula here for the sine A minus sine B. Here is the formula I am applying here in this step. So as we know that sine A minus sine B that is always equals to 2 cos of A plus B, 2 cos of A plus B sine of A minus B over 2. Now I am putting this formula here. So here the whole function, the a is basically x plus h. So x plus h plus the value of the b is here x. So x plus h over 2 and sine as it is, and the value of the a is here x plus h. So x plus h minus, and the value of the b is x. So this is the x as it is over 2, and the 2 from the formula, this one is here, like 2 cos of x plus h plus x over 2 sine of x plus h minus x over 2 divided by this h. Now in the next step, I'm now adding these two x's, so it becomes 2x plus h, and here these two x's cancel out, so only h over 2 remaining. So 2 cos of 2x plus h over 2 sine of h over 2 divided by, now if I multiply this h with 2 and also divide with 2, that doesn't matter. So I'm multiplying and divide 2 here, so I have this result like this. Here this 2 divided by this 2, I mean this 2 cancel out with this 2, so cos of 2x plus h over 2, this is the term remaining, and sine of h over 2 is divided by this h over 2, so this term remains here. So this function, when I apply a limit that h approaches to 0, then h over 2 approaches to 0, then if limit h over 2 approaches to 0 sine h over 2 over h over 2, then that result is always equals to 1 according to this result. So I am putting 1 in place of this one, and this result remains as it is. But here in the place of the h, I put the value 0 because h approaches to 0. So 2x over 2, normal cancel this 2 with the upper 2, so I got only result that is cos of x. So this is the derivative of the sine x.